break-even point. What's a break-even point? Break-even point is the point at which your revenue is equal to, your revenue is equal to your cost. So it means that you are not making any profit. The sales that you do, the sales of products or services, just covers the cost. Okay, so it means that you are covering the cost, you are not making any profit. You can look from two perspectives here. One perspective is, if you are not making any profit, why are you doing this? On the other hand, you can be happy from the other perspective and say that at least you are not losing money. But the thing is, it's not sustainable. You need to make profit to continue your company, your operation. But the break-even point is important to make decisions, to understand the best alternatives for you. An important thing about this is this, this statement. The profit maximizing point is not always the revenue maximizing point. This is very important. When you maximize the revenue, as I tried to explain in the previous lecture, when you maximize the revenue, it doesn't mean that you are going to maximize the profit. You need to consider the relationship between the cost and the demand. When I say volume, it means the amount of production or demand. So this cost-volume relationship must be considered, and this should be related to the revenue. I will show you it graphically. Of course, in order to make profit, your costs should be as small as possible. And for this, you can try to reduce the cost by in your engineering design and operation strategies. Okay, minimizing the cost with some techniques is important. If there are alternative designs, if there are alternative materials and etc., you can select the best alternative that minimizes the cost. But on the other hand, it should satisfy all the technological requirements. The strength of the design should be satisfactory. You cannot say that, okay, I minimize the cost by using a cheaper metal instead of a stronger steel, but the strength of the final design does not comply with the customer request. You cannot say that. Okay. So, you know, we categorize the cost as fixed cost and variable cost. Okay, and the fixed cost, the total cost, is a summation of the fixed cost plus the variable cost. We know it. On the other hand, this variable cost, if you focus on this one, it is variable. What does it mean? It changes with the level of the activity. What does the level of the activity mean? If you are considering a manufacturing system, the level of the activity is the production level or the number of items that you are selling, which can be measured in terms of demand. Okay, so this D, sometimes it is the demand of the customer, sometimes it is the quantity that you are producing. Okay, simply it is the number of items. You can think about this as the number of items. And this CV is the unit cost of one item. Okay, unit cost of one item multiplied by the total number of items gives you the total variable cost. This CV, capital CV, is the total variable cost. In order to find the break-even point, remember the break-even point where the revenue is equal to total cost. There we can consider two scenarios with respect to the price. The first one is, we can assume that the price or the demand is a function of price. Actually, this is a more realistic assumption, more realistic scenario. And it says that as the price, this is law of demand, as the price increases, the demand decreases, and etc. So there is a relation between demand and price. But in the second scenario, which is the simplest one, in some cases you can assume that this is correct, but the above one, scenario one, is more realistic. And it says that the price and demand are independent of each other. Okay, however you change the price, you will obtain the same demand level. So we will consider these two scenarios one by one. The first scenario, we assume that the demand is a function of price. Okay, so the fixed cost, this is the quantity, the demand, okay, the number of products. If you look at this graph, the fixed cost, it is independent of the level of activity, independent of the number of products. Whatever the number of product is, we have the same fixed cost level. If the number of products is 100, the fixed cost is this. If the number of products is 200, the fixed cost is the same. But on the other hand, the variable cost changes with respect to the level of the activity. And simply, we have we have such a function for the variable cost. This is CV, total variable cost. And as you can see, when the number of items is 100, the variable cost is this much. When it is 200, the variable cost is this much. And when we consider the total cost, which is the summation of fixed cost plus the total variable cost, as you can see, we are adding this line and this line. And their summation actually is this one. This is the total cost. Okay? So this is the cost function. What about the revenue function? Usually, the total revenue function is a concave function in this form. I'm saying it usually, okay? And when you look at this shape over here, as you can see, there is this point, which is the maximizer of the total revenue function. But can we say that this is the maximizer of the profit? For this, we need to analyze the profit. Where is the profit? The profit is this region over here, where the revenue is higher than the cost. As you can see, the revenue function is larger than the cost function. And this region, it is the profit region. And what does it say? For example, if we are producing, let's say at this level, let's say this is quantity 50, my cost will be this much, my revenue will be this much, and the profit will be the difference between these two. If I produce, let's say, at this point, which is, let's say, 200, cost is this much, revenue is this much, and the difference is small, which is profit. If I decide to produce 250 items, revenue is this much, cost is this much, revenue minus cost is negative. So I'm losing money here, it's not profit. And as you can see here, let's say this is 100, cost is this much, revenue is this much, and if you look at this, the largest difference is at this point. So this is the maximum profit point. But as you can see, the maximum revenue point is this one, maximum revenue. And as you can see, the difference at this maximum revenue point is this much, but it is different than the maximum profit value. Because at this point, the cost is larger than the cost of this one. Although the revenue is also larger, the cost increases at a higher rate than the revenue. So the maximum profit appears at this point. Okay, so it's important to know that the maximum profit point may not be the same as the maximum revenue point. On the other hand, where are the break-even points? As I told you, the break-even point occurs when the revenue is equal to total cost. Okay, so this is the revenue function, this one, and this is the total cost function. And when they are equal to each other at these 2 points. So these D1 prime and D2 prime are the break-even points. And this D star is the maximum profit point. Okay? So we can, this is the same figure, same shape. This D1 prime and D2 prime are the break-even points. This is the maximum revenue point. And when we look at these break-even points, this D1 prime, at this point, total revenue is equal to the total cost. But what happens if I increase my quantity 1 more unit? I move to this side. What happens? At this point, as you can see, I can do some profit. What happens if I move a little bit left and reduce the quantity? As you can see here, I'm losing money. So this is negative, this is positive. So this is the profit region. This is the amount of money that I am losing at this D1 prime. On the other hand, what happens at this D2 prime? If I increase my activity a little bit more, I move to this point, and as you can see, I'm losing at this point. But if I reduce my activity a little bit to the left here, it means that I am making profit. So depending on which break-even point you are in, sometimes increasing the level production, the amount is more beneficial so that you start making profit. But sometimes by doing this, you start losing money. So you need to know what exactly going on. If you have this graph, if you know this graph, you can immediately say what's going on. But assume you don't have this graph, but you just have mathematical equations. Then somehow you need to understand what's going on. Should you increase the amount of production or reduce it to make more profit? It's very important. Okay, there are some certain conditions to obtain maximum profit. So assume at any volume or at any demand level D, we know that the profit is equal to total revenue minus total cost, right? Total revenue minus total cost is the profit. Okay, then remember, total revenue, what was total revenue? P minus D, P times D. And what is this P? It is A minus BD, if we assume a linear price function, times D. And it means that we have A times D minus B times D square. So this is total revenue minus this total cost. Remember, the total cost, we said that it is the fixed cost, total fixed cost, plus total variable cost. And this total variable cost is, in fact, this unit variable cost multiplied by demand. So it means that here we have total fixed cost plus unit cost times demand. This is the profit. If we reorganize these terms, we obtain this. Minus B times D square plus A minus CV times D. I just reorganize. I'm just reorganizing it. Minus fixed cost. Okay, so this is the total profit function. Now with this total profit function, what we can do? We can take the derivative of this one and make it equal to 0 to obtain the profit maximizer point. Of course, we need to check if that point is a profit maximizer or not. Also, we can set the total revenue, this one, equal to total cost. I mean, this function equal to this function to find the break-even points. Now let's find these points. Let's identify these points. But look at this equation over here. This is minus b times d square plus a minus cv minus cf. And look at this first term here. It is negative, you see? Look at this last term here. It's also negative. And this is profit. And at the end, if you want to have a maximum profit, what you should get here in the middle term? You should get a positive value from there. So it means that this A minus CV times D should provide a positive profit for you. Only the positive term is this one. Of course, this A, which is the intersect of the price function, this is the variable unit variable cost. So this A should be larger than CV, and it should provide a positive value so that it will cover all these negative ones, and at the end you will end up with a positive profit. Also, you can say this, in order to make profit, your total revenue must exceed your total cost. If you do this, if you satisfy this, then you are making profit. Then how we can find the maximum profit value? By simply taking the derivative of this profit function with respect to d. And when you do this, I'm taking the derivative minus 2bd, okay, plus a minus cv. Okay, so this is the derivative. And when we make it equal to 0 to find the extreme point, we see that this demand, optimum demand, so I'm putting a star here to indicate that this is optimum, it is equal to A minus CV divided by 2B. This is the point that maximizes this is the extreme point, by the way, and I need to understand if this is a maximizer or not, then take the second derivative of this one with respect to d, and you see that it is minus 2b, and since minus 2b is negative, then this is a maximizer. Okay, this check is important to understand if the point that you found is a maximum or not. Okay, these are the equations that I already wrote. Now, we can find the break-even points also, as I told you, where this total revenue function should be equal to the total cost function. And remember, total revenue function is A times D minus B times D square. So don't be confused about these things. You need to take your pen and pencil while studying this and write these by yourself. You should be able to say that, okay, the price function is A minus BD and etc. The starting point is there. And then if we multiply price with demand, then it is the revenue. Then it gives us AD minus BD square. And then the total cost, it is the total fixed cost plus variable cost. And the variable cost actually is the multiplication of the unit variable cost with the demand. So it is unit variable cost times demand. And if I equate these two to each other, then it will give me the break-even point. But look at this shape. How many break-even points are there in this shape? Simply, there are two break-even points, like, right, this one and this one. So it means that when I solve for this equation, I need to come up with two solutions. Let's see. Shall we get two solutions here or not? So I'm reorganizing everything. It's minus BD square, okay, plus A minus CV times D minus CF, which is equal to 0. Now I want to find the values of D that makes this equation equal to 0. So it means that I want to find the roots of this equation. And how do we find the roots? Of course, if there are numbers over here, you can just find it easily. But if you don't have the numbers, you can use, discriminant. And according to that discriminant, the roots will be minus b. So remember, for such a equation, ax squared plus bx plus c equals to 0, the roots of this equation is minus b plus and minus square root of the discriminant, which is b squared minus 4 times a times c, divided by 2a. So these are the roots, d1 and 2, if this is a quadratic equation. You obtain the two roots by solving this. And then for our case, I'm writing minus b. So b is a minus cv. So minus a minus cv. Okay. Plus minus square root of b square, which is a minus cv square, minus 4 times a, which is minus b, times c, which is minus cf, okay, the square root of this one, divided by 2a, which is 2 times minus b. Okay, so from here, when you use the plus sign here, you will obtain one root, and when you use the negative one here, you will obtain the second root. It's just that easy. But of course, look inside this square root. We have this CF, which is negative. We have this minus 4b, which is negative. Okay. So, I mean, when you multiply these negative ones, this negative and this negative, it will be positive, but there is a negative value here. And at the end, this part all over is negative. So if this part is also negative, then from this square root, you will not be able to get a real number. So it means that this a minus cv should be greater than 4 times b times cf, greater than or equal to, we can say, so that you will get some real roots. Otherwise, if this is not the case, you will not obtain any roots. It means that the cost function and the revenue function does not intersect. How that can happen? Let's assume that our cost function is like this and our revenue function is like this. Where they are intersecting? They are not intersecting anywhere. So if you have this condition, you will have such a situation. It means that there is no break-even point. Otherwise, if they intersect, so you will have two roots. By the way, sometimes you can have this condition. The revenue function is just touching the cost function at a single point. And at this time, when you solve this equation, you will obtain just a single solution. Whenever you use plus or minus, you will obtain the same solution. So it is the multiple root at a single point. Okay, these are the cases that you can have by solving this. Of course, these are the equations. Let's consider an example at the end of this course in 5 minutes. Let's solve this example to understand the concepts better. Okay, this is an example from your book. It says that a company produces electronic timing switches that is used in consumer and commercial products. Look, sometimes I see that some of you, the students, try to understand everything in the question, and they see, okay, there is a company which produces electronic timing switch and etc., etc. Actually, these are irrelevant for us. It is just the story of the question. Don't be focused on too much on these things. For us, the important thing is the data of the problem. Okay? Don't be considered what this company produces. It is the timing switch and etc. This is the story. Let's look. It says that the fixed cost is $73,000 per month. The units are important, so pay attention to the units. And the variable cost, CV, is $83 per unit of item. Okay, CF is given, unit cost CV is given. The selling price per unit, as you can see, depends on the demand, and the selling price is given. Based on equation 2.1 and etc., it says for this situation, determine the optimal volume for this product and confirm that a profit occurs instead of a loss at this demand. Now, one way to solve this problem, which I don't prefer, which I don't suggest you, is to say that, okay, this is A, this is B, okay? So we have now everything. And as you can see, it says, it asks for optimal value. And as you can see, the optimal value, the formula is this one. So you simply adopt this formula and say that A, part A, it is A minus CV divided by 2B. This gives us the optimal demand. But I don't suggest you to do this. Don't do this. It's very simple. Just do this. Write the profit function, which is the revenue, total revenue minus total cost. And total revenue is price times D minus total cost is fixed cost plus variable cost. Unit variable cost times D. And this price is given as a function here. So for profit, we have 180 minus 0.02. I know it can be a little bit longer, but you don't need to memorize anything, and you know what's going on. You know the idea. Okay? Minus, you have this CF, which is 73,000 plus CV, I'm just plugging in the values, 83 times D. Okay, so this is the profit function. And if we reorganize, we have this 180D minus 0.02 D square minus 73,000 minus 83D. This is the profit function. After you obtain this profit function, just take the derivative of this one with respect to D, and you will obtain 180 minus 0.04 D plus 83. And from here, you will obtain your D when you solve as 2,425 units. Of course, you need to check if this is optimal, if this provides a profit or not. And how do you check? You can check in different ways. You can check the second derivative of this function and see that it is negative. So the first derivative is this one, and the second derivative is minus 0.04, which is less than 0. It means that at this level, you are making a profit. Or what you can do, you can just take this demand value and put it inside this equation, and you see that it is a positive value. We should have minus 83. Okay, so if you want to find the maximum profit value, maximum profit, then simply we plug in this demand value into this equation. Okay, minus 73,000 minus 83 times 2,425. And when you do this, I think the value that you will obtain is $44,612. This is the maximum profit that you can get at this demand value. And in part B of the question, actually it asks for the break-even points. And in that case, simply you need to equate total revenue to total cost and solve for it. So let me show it, since we don't have time, let me show it here. We set total revenue equal to total cost, and this is the equation that you get when you plug in the values. We obtain this equation, and using this discriminant, you can calculate the two roots. In the first one, we use the plus sign here, and in the second one, we use the minus sign here, and we obtain these two roots. And what does it mean? Actually, in this formula, we obtain this total revenue function like this, and total cost function like this, and we found two break-even points. One is 932, the other one is 3,918. And as you can see, in between these two values, we are making profit. And if the value is 2,425, we are making the maximum profit. But if it is less than this one, or if it is larger than this one, if we are inside this region, we are still making profit. It is less than the maximum profit, but still we are making profit. If you like, you can solve the same question by writing this total profit function using the formulas of Excel, and you can solve it in Excel spreadsheet. Excel is very useful to solve these kind of problems.